Okay, Bismillahirrahmanirrahim. Assalamu alaikum kids. This is Shehroz Abdullah and today we are going to discuss chapter number 18. All the MCQs with their solution manuals we are going to discuss on board. The right option of the MCQs are already written over here. I'll explain it and make you understand it one by one with their solution manuals. Okay. Coming towards first MCQs, let me read the statement of the first MCQs. It's available on page number 253. It's available on page number 253. You can see. Now, read the page number 253, first MCQ. It says MCQ number 1. What is the number of neutrons in plutonium P252 and 92? So, right option is 150. Option number C is the right option. I'm showing you how it comes. See the solution manual of first MCQ. As we know that number of neutron is equal to atomic mass minus atomic number. So number of neutron atomic mass is how much? 242 minus atomic number is 92. You are going to get 150. Okay, so this 150 neutrons are available in plutonium. Okay, coming towards question number 2, it says which one or more of the three decay processes alpha, beta and gamma results in new element. You know alpha and beta. Alpha reduces the atomic number by 4 and alpha reduces the atomic number by 2 and atomic mass by 4, and beta just decreases 1 electron in that. And gamma is only that element which is gamma is basically in form of rays, which shows you energy, which cannot bring any change in which cannot form any new element, but it can just turn gamma can turn the element from unstable to stable state, while change in atomic number and atomic mass can be brought only by alpha and beta, because alpha and beta are particles. Because alpha and beta are particles, while gamma is not a particle, it's a ray, it's an energy. Gamma just only turns the element from unstable state to a stable state only. So in the question says that, question number 2, which one or more of the three decays, alpha, beta and gamma, results in a new element? So alpha and beta both can bring change and can bring new elements, and new element may form over here because it reduces the atomic number and atomic mass. Alpha changes the atomic mass by 4, atomic number by 2. Gamma only changes atomic number, okay, increases atomic number by 1. Gamma is energy, it cannot bring any change. It only turns the atom from unstable state to a stable state. Okay, so option number D, MCQs number 2, option number D, alpha and beta both are the right option for this MCQs. Coming towards MCQs number 3. It says what type of nuclear decay leaves the number of protons and neutrons unchanged? So that is option number C, what we call gamma decay, because gamma is an energy. It only changes the atom from unstable state to a stable state only. It has nothing to do with changing atomic number and atomic mass. Coming towards question number 4, MCQs number 4. So it says what type of nuclear decay most often produces the greatest mass and charge loss? So definitely that is alpha. Alpha brings the change. Alpha changes the mass or decreases the mass by 4 whenever an element releases alpha. So its atomic mass will be reduced by 4 and atomic number will be reduced by 2. And similarly, if you see beta and gamma, so among all these three, alpha has the greatest ability to bring change in atomic mass and atomic number. Okay, so option number A, alpha decay is the right option of that. Okay, this MCQs 5 and MCQs 6 both are out of course, but still I have done it and let me show it to you. MCQs 5 and 6, these two are out of course. Okay, MCQs 5 and 6 are out of course, but still right options are written over there. MCQ's fifth option is D, and it is Bismuth 210, Bismuth 210 to subscript 83. Bismuth 210 and subscript 83. In book they have written bismuth mass 212, which is wrong. Basically the bismuth atomic mass is 210 and atomic number is 83. So this is how we do, and come to 6 MCQs. 6 right option is B, that is radon, and right. It says coming towards MCQs number 5th out of course, coming towards MCQ 6 which is also out of course, okay, and radium decays, radium 2 to 6 decays by emitting alpha particle. What is the daughter nucleus, right? So this is also out of course. Coming towards MCQs number 7. It's MCQs number 7, most important MCQs all the time when it comes in the paper. What does it say? MCQs number 7, argon 39. This is argon 39. This is the atomic number of argon, okay? And argon, what does it say? Argon 39 is an isotope, okay, with a half-life of 269 years. It will reduce to half in dash years. In how much years this will reduce to its half? Okay, come to the definition of half-life. Half-life is the time taken by a radioactive sample to reduce itself into exactly half of the total present. That is known as half-life of that specific sample. Different elements have different half-lives. If in the question they are saying that argon 39 has a half-life of 269 years, means if 269 years passes on this argon, then this argon will turn to half of the original. If 269 years passes on this argon 39, then this sample of argon will reduce to its half, means to reduce into half of the original present. This sample will take 269 years exactly. And for second half-life, again it will take 269 years. For third half-life, again it will take 269 years. For fourth half-life, again it will take 269 years. Okay. So, for reduce the sample to half of the original present, it takes that much time what we have given with the half-life of the radioactive sample. Okay, which is 269 years. Please understand this question. Okay, it says question coming towards question number 9. Okay, MCQ 7, option number D, 269 years is the right option. Okay, 269 years is the right option. Coming towards MCQ number 8, it says a sample starts with 100 radioactive atoms. Starts with means total number of atoms is 100. Of a radioactive sample, total number of elements is how much? 100. How many half-lives have elapsed? Elapsed means passed when 750 atoms has decayed. It says that we were having a radioactive sample, it was 100 radioactive atoms, okay, and in how much time, in how many half-lives have passed, okay, when 750 atoms have decayed. Okay, look, coming towards member number 8, total number of radioactive atoms is 1000. Okay, after first half-life, this 1000 will reduce to half, means 500. After second half-life, you know, for first half-life this sample 1000 will be divided by 2 and we will get 500. Means after first half-life this sample will reduce to half, means 500 radioactive atoms will be left. For second half-life this 500 will be further half, okay, to 250, right? Okay, for third half-life, okay, now sum it, 500 and 250. 500 plus 250. This is going to give you 750. Means if 750 radioactive atoms has if we add this 500 with 250, right? So we get 750. Means if 750 atoms has decayed, so it took how much half-lives? It took 2 half-lives. According to the question said, in the question it was saying that question number 8, a sample starts with 100 radioactive atoms. How many half-lives have passed? I mean, how many half-lives has passed when when 750 atoms has decayed, so let me find the number of half-lives. Total number of atoms is 100. After first half-life, this 100 will reduce to 500. After second half-life, this 500 will reduce to 250. Let me sum it. So 500 into 50 will give me 750. So for decaying 750 atoms, it takes 2 half-lives. It takes what? It takes 2 half-lives. Coming towards last MCQs of this chapter, what is it says? MCQ number 9. Origin of energy from sun and star is what? Origin of energy from sun and star is fusion. So this was all about today's lecture. Hope you have enjoyed the lecture. Thanks for watching.